quadratic equations unit, and in this lesson we are going to solve the quadratic equations using the formula, the quadratic formula. So previously we have learned different methods to solve the quadratic equations or quadratic expressions. For example, splitting the middle term, which is b over a, or using the taking a common factor when c equals to 0, and sometimes need to complete square. If none of these methods is available or can be applied in a formula, then we use the quadratic formula. This is the quadratic formula. It says that x, or the roots of the quadratic equations, equals to minus b plus or minus the square root of b squared minus 4ac. All of that over 2a. A, B, C are the constants in the quadratic expressions, which is on the standard formula. It has to be on the standard formula ax squared plus bx plus c equals to 0. And this term here, previously we have learned that it is called discriminant. Why discriminant? Because using this formula we decide whether or the number of solutions the quadratic equations has. So this is the discriminant, and denoted by d equals only b squared minus 4ac. Now let's recall the number of solutions it has depending on the discriminant. If the discriminant is, if this term is positive, greater than 0, then we have two real numbers or roots. Let's say roots. If d less than 0 means that we have a negative sign under the square root. So this can't be real numbers. It is imaginary. So we don't have any real number. We have 0 solutions or roots. No solutions, no real solutions, but imaginary. Okay. So if the discriminant equals to 0, exactly 0, then it means that the parabola or the quadratic just touches the x-axis with just one point, so it has only one solution. When discriminant is greater than 0, so two rules, then that means that the parabola, the quadratic formula, cut the or intersect the x-axis in 2 points. But if it is only one solution, it means that it touches in only one solution. Here we have x1 and x2. But if there is no solution when the discriminant equals to a negative number, it means that either the parabola is over or under the x-axis, but neither touch nor intersect. So let's see some examples. All of this, the standard formula, we have explained it previously, and the discriminant number of solutions is just for revision before we start to apply this formula and find the solutions using this formula. So let's take some examples and see how this formula forms. First, the equation, the given equation in the problem, or it has to be in the standard formula. Now let's check. This is x squared plus 5x minus 14 is on the standard form. So we can just start directly find the discriminant, which is equals to b squared minus 4ac. Now b squared is 5 squared is 25 minus 4 multiplied with 1 here multiplied with minus 14, and don't forget the sign. This equals to 25 minus, or negative negative equals positive 56, which equals to 81. Now the discriminant equals 81, it is positive, and we have two real roots. Now the applying in the formula, x equals to minus b always, plus or minus the square root of the discriminant over 2a. This equals to minus b, which is minus 5, plus minus the square root of 81 over 20 over 2 multiplied with 1. This gives us two solutions. First one is x, which is minus 5 minus 9. The square root of 81 is minus 9 over 2, or x equals to minus 5 plus 9 over 2. This gives us minus 14 over 2, which is minus 7. This is the first root. And the other one is minus 5 plus 9 equals to 4 over 2 equals to 2. This is the second root. And that's it, as simple as that. First, you have to check that the given equation or formula is on the standard formula or in the standard form of quadratic equations, and then just find the discriminant to see how many solutions do you have, or whether there is or there are real solutions or no. If the discriminant is negative here, so we can't find real solutions, we have imaginary solutions. So let's see the next example. We said that we have to check first whether the given formula or whether a given equation is on the standard form. Here it's not, so rewrite it so it is on the standard form. 3x squared, which is ax squared minus x. We don't have any other x's other than this one. We take 7 to the side, or just subtract 7 from both sides of the equations, gives us 5 minus 7 equals to minus 2 equals to 0. Now this is the standard form, and we can find the discriminant from here. Discriminant equals b squared minus 4ac. Now b squared, b is 3 squared is 9 minus 4, b here is minus 1 minus 4, a is 3 and c is minus 2. 1 minus 4 multiplied with 3 equals 12, multiplied with minus 2 minus 24, minus minus gives us positive or plus a 24, and this is a 25. It's positive, then two real roots. Let's find out the two real roots. If we find out that this term or the discriminant, it's very easy to find the roots using the formula, actually, because we did the half of the work. So just now apply in the formula x equals to minus b plus minus the square root of the discriminant that we have found previously, and over 2a. In this equation we have minus 1, negative 1 equals positive 1, plus minus the square root of 25 over 2 multiplied with a, which is here 3. Now we have 1 plus the square root of 2 is 25 is 5 over 6, or we have 1 minus 5 over 6. We have 6 over 6, which is equals to 1, x equals to 1, and we have x equals to 1 minus 5 minus minus 4 over 6 or we can say minus 2/3. It is the same, just simplifying the term. Let's have another example where the formula is completely a mess. We have to rearrange it in the standard formula. So in this example, just solve x multiplied with x minus 2 equals to 4. And this is exactly in a complete mess. There is no x squared term, but we obviously know that this is a quadratic because we have x multiplied with x. So we need to rearrange it and rewrite the equation in the standard formula. So we need to multiply this for x squared minus 2x equals to 4, and let's subtract minus 4 from both sides. We have x squared minus 2x minus 4 equals to 0. Now we have the standard form of quadratic equations. We can find the discriminant, which is b squared minus 4ac and we have here b is minus 2. The square root of the square minus 2 is 4 minus 4 multiplied with 1 multiplied with minus 4. So we have here 4 plus 16 equals to 20. Now to find the solution using the formula, we have to just apply all the given data in the form of x equals to minus b plus minus the square root of the discriminant over 2a. So we have here x equals to minus b is here 2 plus or minus the square root of 20 over 2. We can take out 2 from here, so the square root is 2 plus minus 2, because this is 4 multiplied with 5. This is 4, let's do it, square root of 4 multiplied with 5. So the square root of 4 is 2. We can take 2 out. So x equals 2. We have 2 plus minus 2 square root of 5 over 2. So we have 2 from all these terms taken out. So I have 1 plus or minus the square root of 5. These are the roots for this equation. I have one root when 1 plus the square root of 5. The other one, 1 minus the square root of 5. That's it. I hope that this is helpful for you. Thank you and see you next.